Hello all our adoring fans, and welcome back to Massive Nerds. Today we're covering the Big Bang. What is the Big Bang? This theory presumes approximately 13.6 billion years ago, all matter and energy in the universe was condensed in a space infinitely tiny, like my self-esteem. Suddenly, the universe began expanding exponentially, continuing to this very day. This force is called dark energy, and scientists do not yet understand it. Idiots. What happened after the Big Bang? When it occurred, the universe was extremely hot and dense, but as it expanded, it cooled. Therefore, the building blocks of matter arose. Quarks and electrons, which make up everything we know, formed, and just a few millionths of a second later, the quarks bound together to form protons and neutrons. A few minutes later, they became nuclei. Then, it took 380,000 years, to be exact, for electrons to start getting trapped in orbit around nuclei, creating the first atoms of the universe. Around 150 to 200 million years after the Big Bang, the first stars were formed, constantly producing heavy elements which are spread through the universe when stars explode upon death, called supernova. How was the theory developed? Before the 20th century, only stories and theories explain the origins of the universe, like medieval philosophers and Isaac Newton and Edgar Allan Poe. In 1910, Victor Schleifer observed the registers of galaxies. In 1922, Alexander Friedman solved Einstein's field equations with an expanding universe model. In 1927, Georges Lemaitre proves the universe is expanding, via the Hubble law, and theorizes the universe was once condensed into a primordial atom. Fred House named the theory the Big Bang. From the 50s to the 90s, evidence mounted for the Big Bang theory by disproving the idea that the universe was homogeneous and isotropic, but it was not confirmed. Advances in telescope and satellite technology have taken even more detailed images of cosmic microwave background, showing that the universe must have been hot and dense like the Big Bang at some point, confirming it. Let's discuss some cool scientists who contributed to the Big Bang theory we know and love today. Edwin Hubble observed the sky a lot, no life loser, and saw the universe was expanding. Wow, real wise guy. He measured it with an equation now called Hubble's law, so others could calculate the exact speed galaxies were moving, providing an estimate of when the Big Bang occurred and how old the whole universe really is. Another cool guy was Georges Lemaitre, the first to theorize the Big Bang. He also proposed the expanding universe and proved Einstein's equations were consistent with it. He even found Hubble's law before Hubble himself, who rejected his Big Bang idea. Poor loser. And theorizes the universe was once condensed into a primordial atom. This was built upon and adapted to become the theory we know today. Evidence of the Big Bang. Now, how do we know the Big Bang happened? Well, we have three main points of evidence. First in the ring is the redshift of light, the phenomenon of galaxies appearing redder the further away they are from a point of reference. This supports the Big Bang as it means the spectrum of light emitted by the stars must have been stretched as the universe was expanding. And since red light has a longer wavelength and travels further, it's more visible. Another way of imagining it is the Doppler effect, the same thing that gives planes their whoosh sound. Poo. Up next we have cosmic microwave background radiation or whatever. Before the Big Bang, the universe was extremely hot and dense. Then, as it expanded, matter and gas cooled. Therefore, the universe should be filled with this leftover heat from the Big Bang, which we call CMB, for short. Last but not least, we have the abundance of elements. In the first few minutes of the Big Bang, it is theorized many light elements like deuterium, helium, hydrogen, and lithium were produced. Coincidentally, these are some of the most abundant in our universe, and newer stars like our Sun have distinctly different amounts of them, with heavy elements from the older stars as well. So the fact we have so many of these little guys in our universe, and those scientists noticing that it was produced in the Big Bang, may just be proof that it occurred. Or it's just a coincidence, or scientists making it all up, who knows, not me. Credibility of cosmic microwave background. To make sure, let's examine if CMB is reliable evidence. CMB is actually the best evidence we have in the Big Bang, and over time our measurements have gotten more accurate and more precise, so we're sure the pattern of radiation could only be produced in Big Bang type conditions. Pathetic losers try to integrate it into other models of the universe, such as Richard Tolman's oscillating universe, but cuties like Stephen Hawking showed he was approximately a huge, strong, brain-dead donkey. We are still analyzing CMB, to help us understand the mysterious forces of dark matter and dark energy. One essential show, we'll never stop looking. Let's go, baby! Woo! Hey, hope you guys liked that really cool video. Be sure to like, bell, and subscribe. And check out NordVPN using our code MASSIVENERDS. And if you want to support us directly, head to our new merch at www.massivenerds.com.au/merch/Hubble has no life. See you in the next videos.